So in this video today I'm going to show you how you can simulate latency and bandwidth conditions using the Charles Web Debugging Proxy. So first of all I go to Google and I search for the Charles Web Debugging Proxy download, which I find here, and there's a free trial available which is good for up to 30 minutes. After that you need to shut down the proxy and restart it. In my case I'm going to go for the 64-bit version of Windows, which also needs the 64-bit Java runtime environments. Okay, now I've installed it, I go to the start menu and I run the Charles proxy. We can see it's starting up now. And if we go into the proxy options, we can see that they have the option here for throttling. So if we go to the throttling settings, first of all, we can enable that, and we can have a go for one of the predefined settings here, for example 56k modem or ISDN, or we can put in our own manual settings here. So for example, I want to test with 1024 kilobits, which is 1 megabit. Which is fairly typical broadband connection these days, and that would have usually something like a 256k upload, and the utilization here, I'll put that to 90%, just because you never get 100% of any bandwidth connection. There's usually something else which will be using some of the bandwidth at that same time. And then the last thing here we can set is the latency in milliseconds. So latency is something which will change depending on the geographic distance between the actual client browser and the web server. So for example, in my case I'm located in the UK. If I hit UK websites, I will get latencies of something around 30-35 milliseconds. If I'm hitting a website in, say, New Zealand, which is the other side of the world, I'll be getting a latency of maybe 300 milliseconds or more. So this is important because if you're doing your testing on a LAN environment, you may have very small numbers of milliseconds, like 1 or 2 milliseconds, and you may have bandwidth which is, say, gigabit Ethernet, for example. But in the real world, this is more like what your actual end users are going to have. So here I'm going 1 megabit, 90% utilization. And I'm going to say, in this case, I'm going to give it 100 milliseconds of latency and say OK to that. Now, to use the proxy in Internet Explorer, you have to configure your proxy in the usual way, which is under Internet Options, Connections, and then LAN Settings. Tick the box here to say use a proxy server, and you can actually see in the advanced settings this is already filled in for you. So the Charles proxy is running on the local host IP address, the loopback address there, 127.0.0.1, and it's running on port 8888. So that's actually automatically filled in by the proxy, so I didn't have to enter that myself, but just to show you where you would configure that. If you was doing it for another browser like Chrome or Firefox, for example, you would probably need to enter that proxy setting manually. Okay, so if I visit a website, for example, I'm going to go to the bbc.co.uk website here. In fact, one last thing before I do that is I'm going to just record the response time breakdown for that. There's a number of tools you can use for this kind of thing. So I've got a few installed here. HTTP Watch is a good one. Fiddler 2 is another good one. And I'm going to use the AOL PageTest in this example here, which is going to give us a nice waterfall breakdown of what that page load time looks like. So if I go to bbc.co.uk, you can see now it's waiting. We should see in a second the page just start to draw and a few items remaining, and in a second we'll see it's done. So if we bring up the AOL window, we can see here was where the page was first requested. You can see the style sheets, you can see the JavaScripts, JPEG images, and you can see at this point here, the green line is where the page first started to render, so that's when we got enough information about the page where we could actually start to draw things within the browser. And then the blue line here is where the page was fully completed, and then there's actually a couple of things that load after the page has finished loading, some kind of asynchronous stuff as well there. So you can see that was just about 6.6 seconds, we'll say there, with 100 milliseconds of latency added and a 1 megabit broadband connection. So next we want to see what the impact is of latency on the page load time for this particular site. So if we go back into our proxy settings and we go to change the throttle settings here, enable the throttling again, keeping the settings the same as last time, except for this time instead of 100 milliseconds of latency, we're going to go for 300 milliseconds, and that will simulate the kind of latency you might expect if you was going halfway around the world. So for example, somebody in Australia or New Zealand hitting this BBC website here in the UK. So save those settings. Before we start the test, I'm going to go into the internet options and delete the history again. And then once again, I'm also going to bring up the AOL PageTest to measure the breakdown of response time, and then Control F5 to fully refresh that page there. So the page is loading again, and it's done. So if I bring up the AOL window now to see the response time, you can see now it started to render again at about 2.5 seconds, but you can see now, because of the latency, each of these different elements on the page is slightly more spread out. So there's the extra latency between each of these requests, and now you can see that the page now wasn't actually fully completed until about 10.5 seconds. So if you remember previously, it was about 6.5 seconds. So that's the impact of latency, is each of these elements on the page is getting further spread out. So the way you might make this faster would be to think about having fewer elements on the page. Obviously the more elements you've got, the more latency is going to have an impact. Okay, so I will close that window once again, and next the final test I want to show you, going back into the throttling settings, this time setting the latency back to 100 milliseconds as it was. This time I'm going to decrease the bandwidth, so instead of 1 megabit connection, we're going to go for a 512k broadband connection, keeping the rest of the things the same there, and save that. Again, we'll start the test by going into the internet options and deleting the history, just to make sure we've got an empty browser cache, and then again bringing up the AOL PageTest to get the timing measurements for us, and I will re-request that page, and we can see that it's loading now, and looks like it's completed now. So if I bring back the AOL window again to see the waterfall diagram, so now what you can see, the impact of having halved our bandwidth this time, is each of these bars here is now longer. So each of these, in this case JPEG images, is taking longer to load because we've got less bandwidth there to download these things. So each of these bars becomes longer, and again the cumulative effect of each of these bars being longer is that the overall page load time now is again around about 10.5 seconds. If you remember, the original timings were about 6.5 seconds. So you can see by halving the bandwidth, you've almost doubled the page load time. So that's bandwidth. So you can see that there's two distinct things there, bandwidth and latency, and both of them can play a major impact on the actual page load times.